Good morning, everyone. All right, so lesson 3.1, relations. Now, the word relations basically means how two variables are connected, okay? So, for the first example, work. Let's take a look here. Yeah, so let's say in Ontario your minimum wage is $14 per hour, all right? So, what does that mean? Well, the relation is between the hours worked and the money's paid, right? The more hours you work, the more money you'll get paid. Pretty well straightforward. So if I were to sit down and start working out a table, right? 0 hours, 0 money. 1 hour, 14, 2, 28, and so on. Okay? Don't worry about the red writing just yet. I'll come back to that. All right, so the first thing we need to talk about is the variable x. X is known as the independent variable. And what does that mean? The independent variable is what drives the equation. Okay? So if I know how much time I've worked, I can tell you how much money I should be expecting. Well, the amount of money coming in is what's known as the dependent variable, the result of whatever x does or creates. Okay? All right, so that's basically the difference between independent and dependent variables. Next, if I'm given a table of values, there's a few ways to know if it is or is not linear. First of all, if they don't tell you anything, in other words, what type of graph it's going to become, right? I can do one of two things. I can put the points on the graph, take out the ruler and see if it's straight and connect them, or I can do something called the first difference, okay? So the first difference works like this. It's called a difference because we're subtracting. I would look at my table of values, make sure that my x terms are ascending as we go down. Okay, in other words, they're getting bigger in an organized fashion, and I would put their y partners with them. So if they mixed up the question, different points, different places, it would be easier for me to solve if I would have put them into an order. Okay? Next. It's called first difference because I'm subtracting. For example, 42 subtract 28. That gives me 14. If you keep going, 28 subtract 14, 14, and so on. Okay? So you'll notice that the first difference on the y side is constant. So what I'm going to do is I'm going to check on the x side to make sure that it is constant as well. Okay? So 3 subtract 2, 2 subtract 1, and so on. Okay? So as long as the first differences are constant, then the relation is linear. In other words, these numbers will produce a straight line when you connect the dots. All right? All right. Now, most people cannot be doing table of values forever. So what they're looking to do is they're looking to come up with some sort of form of an equation. And the first one we'd like to introduce is y equals mx plus b. Okay? So I'm going to use the same example as before, and the reason is very simple. You've seen it, all right, and you know what the numbers are, and we've already said that it is a straight line. So now what we're going to do is we're going to come up with an equation that fits it. All right, so step one, we need to solve for the slope, okay? Now the slope is the angle that the line is rising or falling at, okay? So slope. Now, there's many ways to look for slope. Okay, slope is all of these different things. For example, slope is rate of change, rise over run, and if I'm not mistaken, in your earlier grades, you would have seen rise over run is equal to this amazing formula, y2 minus y1 over x2 minus x1. Okay, that's known as the slope formula. And finally, what they call delta y over delta x. Now, delta is the triangular symbol in front of the variable, and basically it means the change in y divided by the change in x. To stop being fancy with all these terms, basically the first difference is the change in y, and the other first difference is the change in x. Okay? All right. Let's keep going. All right, so how do we start coming up with an equation? Well, step one, solve for the slope. What did I do? I used any one of these formulas on the right to come up with what my slope is. Delta y over delta x seemed easy enough, so 14 divided by 1. Take the slope, put it in place of the letter m. So far you are now at y equals 14x plus 0. To solve for the 0, okay? You can pick any other point in your table. Doesn't matter. As long as you use x and y properly, you will solve for the b factor. Okay? Now there is a name for the b factor, and that is the y-intercept. Okay? Let me just raise this up a bit. So, for example, there's my equation so far. I've plugged in 2, 28. So there's 2 for the x and so on. I'm going to solve for b. When I work it out, it turns out that b is actually equal to 0. So my equation should have been y equals 14x plus 0, but nobody shows the plus 0. So effectively, this equation is just strictly y equals 14x. All right? All right. Reasons for this equation. Well, for example, once I have this pattern, right, I could say, hey, this week I worked 19 hours. Well, instead of doing a long-winded table, I can go 14 times 19, and there's your answer. Okay? All right, but let's say 19, okay, sir, I could have done this table fast enough. Yeah, true. But let's say you've worked a month, 47 hours. So you're going to tell me you're going to do a table up to 47 hours? Nobody's going to do that. But once we have the equation that represents this line, we can punch it in, and $658. Very simply and quickly. All right, well, there's more to it than that. Let me just slide up to the next page. It also works in reverse. For example, let's say I want to know how many hours do I need to work if I want to make $1,000. Okay? All right, well now it's a little different. So I'm going to substitute 1,000 into the y position because y was the total monies made, equal to 14x, the original equation. To get x by itself, I'm going to divide both sides by 14. Okay, so you need to work at least 71.43 hours. Or, I now know I have to work 71.5 hours so that I can earn the $1,000 and a little bit extra. Okay? So that becomes the advantage of being able to use an equation. All right. So let's get back to these first differences. So what I did was I came up with another example. All right. So here's a new set of tables, coordinates, and you'll see that on the x side, right, it works. On the y side, it happens to be follow the pattern of -5. So every time I subtract, I've got -12, subtract -7, -5 is my difference. So this time you'll notice that two things. The difference is constant on both sides. But now I've got a negative difference and I don't have a difference of 1 on the x side. Doesn't matter. As long as the two differences are constant, then what you've got now is you've got a linear equation. So I'm going to use delta y over delta x again, right? Gives me negative 5 over 3. I could have used the slope formula, m equals y2 minus y1, x2 minus x1, and that works perfectly fine as well, okay? We'll come back to that one in a later date. Once I know that my slope is negative 5 over 3, I put the m into the equation. Once I know that, now I need to figure out the b part. Now if you remember from above, right, I could pick any of these points, sub in my x and my y, and solve for b. Well, I did that. I substituted in 3 comma negative 7, which gave me the negative 15 over 3, which gave me negative 5 as a resultant so far. So to get the b factor, I had to kick the negative 5 to the other side. Negative 7 plus 5 is my b factor of negative 2. This now gives me the equation. Okay? All right, there is a shortcut. If and only if the table of values is kind enough to give you a 0 for the x position, then its partner on the y side is automatically your b. Okay? This is what they call the y-intercept. All right, the y-intercept. It works well, and you'll see as we move forward how it works. Anyway, have a good day.